Matthew, thanks for coming in today. I'm really excited to talk to you about your research.
Thanks, I'm happy to be here.
Yeah, first tell me a little bit about yourself.
Sure, so I'm Dr. Matthew Guzdial. I'm a Amii Fellow and a Canada CIFAR AI Chair, and I'm an Assistant Professor at the University of Alberta.
So a lot of your work is in the domain of computational creativity intersecting with machine learning. How would you define computational creativity?
Computational creativity is basically the attempt to take human cognitive creative practices or processes and trying to transform them into some computational process, which usually means some sort of algorithm. If I tell you, for example, come up with a brand new animal that doesn't exist, almost always the thing that your brain does is it combines existing features of existing animals, right, to come up with something new. Mm-hmm. So that's referred to as conceptual blending or cognitive combination or conceptual combination, depends on what kind of cognitive scientist you're talking about, right? But that's a process so that we can then come up with algorithms to try to replicate in computers to try to solve problems. And broadly, that's computational creativity.
So how does that intersect with machine learning? Like, how do those things interact?
Through a number of ways. So one, we can think about, okay, can we take things that we would typically think about as requiring human creativity and apply machine learning to them, right? So that's how you get the sort of generative AI sort of space of things, right? We can think about, are there problems in machine learning, for example, like how do we deal with very low data problems or very varied problems or out of distribution problems, right? That humans typically solve by sort of creative thinking, right? Out of the box thinking. Yeah. Can we take those processes and then apply them to machine learning algorithms to improve those more generally?
So now that we've set the stage a little bit about computational creativity and machine learning, how does your research fit into this?
I do a lot of work in video games. This is partially because that's sort of where my expertise is, and it's where, unsurprisingly, a lot of student interest is.
Yeah.
And I was at Zynga, I was at EA Sports. I did the sort of attempt to be a video game developer thing. Yeah. And I said, nah, not for me, but I still have all that knowledge. So that's where a lot of that comes in. And so we're really looking at a whole bunch of problems within the video game domain that are sort of unique to that domain. Unlike images or text or even sound, we don't have really good representations that are sort of general representations for a whole bunch of video game knowledge. So it means even despite the fact that there's, probably 1 million games, published games at this point, we can't really generalize over them or use that as a data set in the same way that we can use a whole bunch of text as a data set or a whole bunch of images as a data set or low data just generally, how do we deal with that? Or human in the loop stuff, how do we deal with that? But then a lot of what I try to do then is say, okay, we can think about video games as sort of a simplification of reality, right? And so are there ways then that we can generalize what we've learned from video games and apply them to domains outside of games?
Right. Yeah, you have, truck driving simulator, and then that generalizes into actual truck driving or something.
Sure, yeah. That sim to real paradigm is very, common, right? Matt Taylor's done work in that. A whole bunch of other great people here at Amii have done work in that space.
Totally.
Since I tend to do more things on the design side of things or the generation side of things, it's a slightly different setup.
Right. So what got you into this video games and procedural generation / computational creativity space? I'm assuming you probably play video games yourself.
Yeah, the thing that got me into it was actually way back being an undergrad. I ran this undergrad game development club. And we would always have these students show up who would have no technical skills whatsoever, but who were desperate to make games because they loved games and they wanted to be making games, right? And I really wanted to make things that would help those people express, and just as artistic expression, allow them to make games. If you think about writing, for example, you or I are not, I don't know about you. I'm not a fiction writer, right?
No, me neither.
But either one of us could sit down with a word processor or just a notebook and start writing, and eventually it would get better, right? It might take a while. And the same thing for visual art, the same thing for music making. It's very accessible as an artistic practice, but video game making is not. And so I was trying to find ways to think about solving that. And that got me to procedural content generation, which you already mentioned, right? Which is sort of generally non-machine learning approaches like search-based approaches, which we talked about already, or constructive approaches or constraint-based approaches, et cetera. There's lots. But the problem with those is they require still a lot of human knowledge, like a human design knowledge. Like you can't just use these approaches and not know how to make a game. And they also have a lot of technical requirements. You have to be able to actually program these things yourself, which meant that they were sort of a dead end for the thing I cared about.
Right.
And that got me to machine learning. And this was back in like 2015, 2016 that I started doing this.
Yeah, like the stone age of machine learning.
The stone age. Back in my day. We still had machine learning. It just wasn't, after the deep neural network revolution.
Yeah.
And so looking at ways that we could extract the kind of design knowledge required, right, automatically via machine learning, rather than having to have a human hand author it, was really what got me there.
Right. So what does the data extraction process actually look like?
Totally. It varies widely depending on what we're doing. For example, I have this old work now from like IJCAI 2017 on trying to learn rules from gameplay video.
Okay.
So like watching somebody play a game, try to extract rules that would allow you to simulate the game they're playing.
Okay, like rules of the game.
Rules of the game that they're playing, right? So like we're watching Mario jumps, Mario hits a Goomba, the Goomba disappears, right? How do we learn a sequence of literal machine code that can allow us to simulate that such that we can imagine alternate things there and we can like run the game, run a simulation of the game.
So it's sort of like building a model of the game, essentially.
Totally is. This is Hans Schmidhuber would later cite that work when they were originally proposing world models as a concept, right? You learn an entire model to represent the game as a single deep neural network, or a few in that case.
So shifting gears here a little bit, what are you most excited about that's going on in your lab right now?
Oh, that's a tough question.
Or maybe a few exciting things that are going on.
Okay, that's more reasonable. I appreciate the generalization of the question. So one that I'm really excited about right now is this mechanic maker project we're working on.
Okay.
Which is basically this sort of co-creative tool, which is like human and AI working together tool, but for game mechanics. So like, Mario jumping or shooting something with a laser and it explodes or whatever, right? There's been a whole bunch of like no code or low code tools, things like, MIT's Scratch, for example, you might have heard of, or Alice, or like Sony had this game called Dreams, which was sort of like this. You can even do sort of the same thing in like Roblox, for example. But all these still require you to program. It's just they're often in a simpler interface, like a block-based programming interface.
Right.
But in this case, what we have is a situation where we have this back-end AI, which is just watching the human user make demonstrations of this is the mechanic I want to happen, right? And like placing things on screen and moving them to say, when this happens, do this, right? So I could like show a character when I hit the right button going to the right.
Okay.
And then the back-end system actually generates the code to say, oh, when the right arrow is hit, move the character to the right. Now you can play it, and it will just work.
So is it fair to say that it's like program synthesis from demonstration?
Yes, that's a fair way to say it, for sure.
Okay.
It's a little bit weirder than that, because we actually have this learning agent in the back end. It's the same one, actually. Well, not exactly the same one. It's a grandchild of this one from this IJCAI 2017 paper we were talking about a while ago, right, of like the gameplay video thing. But, if we have an interface, we don't even need to do gameplay video. We can just directly see, hey, here's the mechanics that you're demonstrating for me.
Right. And does it always like learn the mechanics accurately?
So there's some cases where it doesn't. If it, so we're assuming a Markovian state.
Sure.
Right? So we're assuming that we have no hidden information, which is not great because a lot of times human demonstrators will just assume we have some hidden information that we don't actually have, right? So if you're trying to set up something where like, there's like a cooldown or something on an ability, or like there's a like hidden inventory or something like that. This won't work, right? We have to see everything.
Right.
And it also won't work if the human users create a contradiction.
Okay.
So if they do something like, okay, every 3 frames I have this character jump, but then on frame 5, I also have the character jump.
Yeah.
They'll just get into a contradiction. You won't be able to learn the thing you want.
Okay.
Right.
Does it learn something else that's weirder, or?
Yeah, it learns something more specific.
Okay.
So the way that the actual learning process works is it sort of assumes we're trying to learn first the most constrained version of the rule.
Okay.
So like everything that just happened has to happen exactly like that for it to happen again.
Okay.
So not only am I hitting the right arrow, but also there's a bird in the sky, and also there's a ground block over here, and also there's a bush, etc.
Right. Yeah, I feel like this gets into like Occam's razor kind of stuff. Like
Exactly.
the simplest model possible.
Exactly. But then as it sees additional examples of this happening, it will generalize from there, right? So it'll iteratively remove the things that are not important and keep only the things that are.
Right.
And so that means that if you do something weird, like say, okay, if I hit space, I shoot a laser, but this time I hit the A button and I also shot a laser. What it's going to learn is, okay, I'll generalize this space one. And also there's this weird other rule that's like really specific and will never happen about if you hit the A button, there's also sometimes a laser.
Right. Shifting gears here a little bit again, has this affected how you view like creativity in humans, like working on creativity with machines? Like, do those things behave similarly, do you think, or are they like completely different like processes that end up like looking the same from the outside?
Yeah, it's a good question. I think that it definitely has improved my appreciation for the variety of human creative processes. I think a lot of what happens in computational creativity, or we could say generative AI or whatever, is we assume a very standardized way that people do creative tasks.
Okay.
But this is actually not the case, right? We just think about something simple like writing an essay, right? Generative AI, large language models assume that people are going to do this auto-regressively, and they're doing this word by word by word.
Yeah.
But actually, some people do outlines, right? And then they fill that in. Some people do weird things where they'll start at the end and they'll work backwards, right? Et cetera, et cetera, et cetera. So it's more just the diversity, the variety of human practices that are really interesting and compelling. Because there's some really unique ones. You think, oh, wow, that's completely different from how we're trying to solve this problem computationally. Could we try to solve this problem computationally the way you're solving it?
Right. So do you think that these like auto-regressive methods are missing out on this whole wide range of methods that humans do creativity?
Yeah, I think that's a fair thing to say. I mean, it's one solution, which means it's good for some things, but not good for others, right?
Right.
If we're going to stay on the large language models metaphor, right? Because they're not doing this sort of outlining step, right? There's really bad global coherency, right, across generated text, right? It'll quote unquote forget, but it's not that it's forgotten. It's just generating statistically, acceptable text all the time. And if there's nothing that's sort of constraining it to have to be consistent in some way, then it won't be. Right. So I think there's just different ways of solving problems that are sort of more or less appropriate depending on what you're trying to solve.
Right. What do you see are like the biggest challenges in like the computational creativity or the AI and video game space in kind of the next 10-ish years or so?
Right now, there's a whole bunch of people attempting to look at basically how can they just take these generative AI models and try to just sort of shove them into video games and see what happens.
Yeah.
I think the more interesting stuff will be looking at like new kinds of video games that we might be able to get or might be able to make from that. And then I think the other thing that's interesting is looking at, there's been these massive successes in terms of like image generation or image classification or text generation, et cetera, models, and looking at how do you convert those successes for video games. So the biggest companies, so this is like Ubisoft or King or Riot, right? These people who have a ton of data, they've been able to train their own internal models on just their own data. But you don't get a lot of like general models that could like be beneficial for lots of games, right? Or for like little indies starting up and things like that. And so I think we'll see more things in that space of attempting to make sort of broader tools that are useful to more people.
Right. So do you have like various like working relationships with different developers, like getting them to use your research in their like game making?
Definitely have working relationships with a number of developers. I definitely get them to test out some of our weird tools, right? But what I'd really like is to allow anybody to make games. So outside of just like making tools for current AAA developers, I'm also really interested in just like, can I get your mom to be able to make a game, right? Or like your grandmother to be able to make a game? Like how fantastic would that be, right?
Yeah.
And so I think the direction is a lot less, hey, let's make things that are going to make industry more efficient or something, right? And much more like, how do we make this sort of creative practice accessible to most people?
Yeah, just like how some of the other generative AI tools are now suddenly so much easier to use for the average person, you kind of want to do the same for video games instead.
Yeah, though maybe, you know, not in a way that leads people to worry about losing their jobs.
Yeah, yeah. Well, that's all the questions I have. Thank you for joining me. This was a fascinating conversation.
Yeah, thank you. I've been doing it. It was a lot of fun.